Now we are going to start Heron's formula, 12th chapter. In this textbook, 12th chapter is Heron's formula. Okay, my dear children, right. Hero of Alexandria. The formula is credited to Hero or Heron of Alexandria, who was a Greek engineer and mathematician in 10 to 70 AD. Okay, my children, he is a Greek mathematician and also engineer. Amongst other things, he developed Elopile, the first known steam engine, but it was treated as a toy. Okay, my children, right. This Heron's formula was founded by a Greek mathematician called Heron in the year 60 AD. It was invented to find the area of triangles. Okay, my children, the purpose of invention of this formula is to find the area of triangles. This was also mentioned in his book named Metrica. Okay, my children. It was also mentioned in the book of scientist Archimedes, but only in Heron's book was it properly understood by the people. Archimedes also wrote this formula, but the Heron's book was properly understood by the people. Okay, my children. That is why all the credit of the formula is given to Heron. Okay, my children. This is about Heron. Okay, my children. Understood? Right. Who was Heron? Heron of Alexandria, 10C to 70 AD, was an ancient Greek mathematician and engineer who was active in his native city of Alexandria, Roman Egypt. Okay, my children. He is considered the greatest experiment of antiquity, and his work is representative of the Hellenistic scientific tradition. Okay, my children. Heron published a well-recognized description of a steam-powered device called an alloy pile. Okay, my children. Right. About Heron. Heron was also known as the hero of Alexandria or just hero. Okay, my children. There were more than 18 scientists known as a hero at that time. Okay, my children. Right. Much of Hero's original writings and designs have been lost, but some of his works were preserved in Arab manuscripts. Okay, my children. Right. He is said to have been a follower of atomists. Some of his ideas were derived from the works of Ctesias. Okay, my children. Right. More about Heron. He had at least 13 works on mathematics, mechanics, and physics. Okay, my children. Right. He devised many mechanical devices which actually worked practically. One of them was his steam engine. Okay, my children, these are all about Heron. He made and wrote a method approximating square and cube roots of numbers that are not perfect squares or cubes. Okay, my children. Right. He was also one of the first to make a fountain which shoots jets of water upwards. Okay, my children. Right. Now, a question arises in your mind. Why Heron's formula? What is the use of Heron's formula? Why is Heron's formula necessary? Okay, my children. Right. Area of a scalene triangle. If you observe this diagram, this is a scalene triangle. In this triangle, it is impossible to find the height which is necessary to find the area by the formula of into height into base. Hence we need the Heron's formula. Actually we know the area of a triangle means half into base into height, but in the case of a scalene triangle we can't find height. Okay, my children, that is why the need of Heron's formula came into the limelight. Okay, my children, right. The use of Heron's formula. Heron's formula can be used to find out the area of a triangle in case its height is unknown. Okay, my children, if height is known, we can use the direct formula. Area of a triangle is equal to half into base into height. But in case of the height of the triangle is unknown, then we use the Heron's formula. Remember this point, my children, in finding area of a triangle. Okay, my children, the formula can be used for a scalene triangle in which the height does not definitely exist. The formulas can also be used to find the area of rhombus when only one of the diagonal and the perimeter also known or only known. Okay, my children, right. There are many places where the formula can be used. For example, area of flyovers. To find the area of flyovers, we can use the Heron's formula. Okay, my children, right. The formula is credited to Heron or hero of Alexandria, and a proof can be found in his book Metrica, written 60 AD. 60 AD century. Okay, my children, it has been suggested that Archimedes knew the formula over 2 centuries earlier, and since Metrica is a collection of the mathematical knowledge available in the ancient world, it is possible that the formula predates the reference given in that work. Okay, my children, right. A formula equivalent to Heron's, namely a is equal to square root of s into s minus a into s minus b into s minus c, where s is equal to a plus b plus c by 2. This is the important formula for this chapter, my dear children. Remember, my dear children, okay, my dear children, was discovered by Chinese independently of the Greeks. It was published in Shushu, Juhan, written by Queen Juosho and published in 1247 AD. Okay, my children, right. Now you have a doubt. How can we calculate area of a triangle using Heron's formula? Okay, my children, we can calculate area of a triangle if we know the lengths of all sides using a formula that has been known for nearly 2000 years. It is called Heron's formula after hero of Alexandria. The formula can be written as S is equal to A plus B plus C by 2, where and delta is equal to, delta denotes area of triangle, is equal to square root of s into s minus a into s minus b into s minus c. Okay, my children, previously I told you this is the important formula for this entire chapter. Memorize this formula well, my children. Okay, right. Now let us take an example to find the area of a triangle using Heron's formula. Okay, my children. Find the area of a triangle having sides AB is equal to 4 centimeters, BC is equal to 3 centimeters, and CA is equal to 5 centimeters. Okay, my children. AB 4, BC 3, and CA 5 centimeters. Okay, my children. Here, height of the triangle is not given. It was unknown. Only lengths of the 3 sides only known. They are only given. Okay, my children. Understood? Right. Now come to the given data first. What are given here? AB, that is 4 centimeters, and BC, that is equal to 3 centimeters, and CA, that is equal to 5 centimeters. Let us assume that A is equal to 4, B is equal to 3, and C is equal to 5 centimeters. As we know that area of triangle by Heron's formula, square root of s into s minus a into s minus b into s minus c. So first of all, we have to find s value. We have already known a, b and c values. So s is equal to a plus b plus c by 2. This implies s is equal to 4 centimeters plus b means 3 centimeters plus c means 5 centimeters whole divided by 2. By simplifying this number, what will you get? S is equal to 6 centimeters. Hence, we have s is equal to 6 centimeters. Understood, my dear children? Right. Now, we substitute the values of A, B and C and S in the Heron's formula. Then we get area of triangle ABC is equal to square root of 6 into 6 minus 4 into 6 minus 3 into 6 minus 5. Okay. This implies area of triangle ABC is equal to square root of 6 into what will get to 6 minus 4? 2 into 6 minus 3. What will you get here? 3 into what will you get? 6 minus 5? 1. Okay, my children, centimeter square. This implies area of triangle is equal to 6 centimeter square. Understood, my children? Right.